Good day. Today we will begin the new chapter, the point defects, and we begin our conversation about the classification of defects and about the definitions. The plan lecture, the first definition, then the structure and sensitive properties, and the third classification of defects. The physical properties of an ideal crystal is determined by its chemical composition, bending forces between the particles, and the crystal symmetry. In other words, categories, its symmetry classes, and synchronous or Bravais lattice. These properties are called structural insensitive. These include magnetic, optical, piezoelectric, and etc. In real crystals, many properties depend largely not only on the type of crystal structure, but also on the defects of the structure, the frequency of violations, and balance. These properties are called structure sensitive. These, for example, ionic and semiconductant electrical conductivity, luminescence, flexibility, strength, color of crystal, etc. Structural sensitive depend on the structural defects during the crystal growth, plastic deformation, diffusion, and other processes. Structural defects are caused by several reasons. For example, thermal vibrations of atoms, violence of electron density, the impact of any radiation, temperature, etc. All structures defects by geometrical features can be divided into the following types. The first, pointed or point defects in violation of the periodicity of isolating points of the lattice of 3 dimensions do not exceed one or more interatomic distances. Point defects are a vacancy, the atoms in the interstices of the atom are alien substances, impurity atoms. Linear defects, one-dimensional, or extended in one dimension. For example, a violation of the periodicity extends to distances comparable to the size of the crystal, while in others it does not exceed several lattice parameters. Specific line defects, dislocations. In addition, unstable line defects may arise from the change of point defects. The next group, surface. Surface linear defects extend in 2 dimensions at a distance comparable to the size of the crystal, and the third one makes up some of the parameters of the lattice. They are the twin plane, the grain boundaries, and block stacking. And the last group, volume defects. The volume defects, they are voids, pores, particles of another phase inclusions. We emphasize again that all these defects are produced during crystal growth or as a result of various influences and significantly affect the properties of the crystal. The bond defects, what is it? A bond defect is any violation of the crystal structure whose size in all three dimensions are commensurable with the interatomic distance. The simplest bond defects are vacancies and interstitial atoms. A vacancy is an absence of an atom or ion in a lattice site. An interstitial atom is located on an illegal place outside the node in the crystal lattice. Here you can see some point defects, vacancy, and interstitial atom. Look here, please. You can see single vacancy or D vacancy or interstitial atom, white the same atom, and black atom is the atom of impurity. The formation energy of one vacancy is of the order of 1 electron volt, and for the interstitial atom is a few electron volts. Vacancies can be combined into a D vacancy, trivacancy, and vacancy tetrahedron. Accumulation of many vacancies are clusters, form poles, voids, and other volume defects.